Hello and welcome back to the 19th day of this course. Today we are going to discuss about strings in C programming. I know it's a long awaited topic because we have been discussing about arrays since past 7 or 8 videos, but we have not come to strings because it has a separate significance. Strings are in normal language the words or sentences that we write, the paragraphs that we type, the text that we write, all these things are strings, and we do various types of manipulations with string, changing the alphabets, toggling the upper and lower cases, reversing a string, checking whether a string is palindrome or not, making passwords, decrypting and encrypting some text, everything comes under strings. So all these manipulations you can do once you learn how to use strings in C. First of all, what is string? String is actually a character array. So when you keep some characters one after another in contiguous memory locations and form a data structure, we call it a character array, or the common name is strings. One special thing about strings is the last character is always a null character. It's called the terminating character of a string. So if you have to store a name of size 4, suppose, then please declare an array of size 5. So one extra for that special ending character. Here are some ways you can declare a string or use a string. For example, the most common type of string that we use is just text, like the English alphabets from A to Z. However, if we have just zeros and ones, we say it as a binary string, and there are many problems regarding these binary strings. Like in many cases, we have some yes or no decision making greedy problems, and in those cases these binary strings become very handy. Since characters can also include special characters and digits from 0 to 9, you can also make some passwords or store them in strings. That is another aspect. What happens when we deal with numbers which are very big? Suppose you are dealing with long integers and you are multiplying them. There is every possibility that it overflows. So when you get an integer overflow, you get peculiar negative value. So to prevent such things from happening, what we can do is to take the numbers as a string. Now values like 19-digit or 20-digit numbers can be too large for some data types. But for arrays, the size 19 or 20 is not a big deal. So you can simply create an array of character type and fit any big number you want. As simple as that. That's a good use of strings. It can save you from integer overflows. And now let us go to the editor and see how we can implement all these stuffs. To start with, we have this program in C where we have learned how to declare and then how to initialize a string. To declare, I have used str as the name of the array. So since it's a character array, I had to mention the type as character, and then comes the name of the array. This is the size of the array, so I can put 9 things into it because the 10th thing will automatically be the null character. To initialize, you can either manually put the values or the characters one by one, or what you can do is to take a for loop and ask the user to give a character. So for that you need user input, and that we have discussed later. Next comes how to print a string. So there are two methods again. You can either print character by character. To print a string character by character, we use %c as the format specifier and just print the ith element of the array, which prints your string. Otherwise, you can use %s as the format specifier to print the entire string at a time. Let us check it. So when we run this program, we find that we have taken a vowel string, right, a, e, I, o, u, and we are getting that string printed character by character with a space in between because of this line. Then we have printed the entire string at once, so there was no space in between. A, E, I, O, U was together a single string. After that, we have tried to print the integer value. So if we try to print the integer value character by character, we will get the ASCII values, right? That means the ASCII value of A is 97, the ASCII value of small e is 101, and correspondingly all the ASCII values has been printed. Why do we get all the zeros here? Because when we come to this line, we see we are printing something from index 5 to index 9, and we do not have any characters placed there, so the default value is 0. Since we are expecting an integer, we have given %d, right? That's why we are getting an integer value that is 0 because nothing is present there. If we try to make it %c, then what happens? Now let us run it, Control S, and we run it. Yes, now you can find nothing is printed. Actually nothing is present. So when nothing is present in a character array or a string, and we try to print the character, we get null character. But if we try to print the integer value of null, as we have discussed earlier, we know that null's equivalent integer is 0. That's why we are getting 0. What happens if we try to access something that is out of the length of the array? So suppose this is array of length 10. If I try to go up to 17, what happens? And let us change the format specifier to %d. Still you will get 0. That means It does not matter whether you are printing within the range or out of the range. If no values has been inserted, you will get 0. That's what we have for the first program. Let us proceed to the next one. Here we have dealt with accepting input from the user character by character. How to take that? First of all, I am asking the length of the string. Suppose user gives the length and I store it in len. Then I declare an array, a character array with the name C and the length len. I am accepting input character by character. I can either use scanf %c as the format specifier so that I take one character at a time, or what I can do is I can use something called as getChar. So getChar is also another function that only takes, let me write it down. Alternative is getChar, and correspondingly to print a single character we use putChar. We have discussed it already, right, earlier. Let us try and test it. Enter the length of the string, so suppose 3, and I give Tom. So Tom is the name. So I got only T and O. What is the reason? You may pause the video and think on it. Since my size is 3, so I can store two things, right? The last element has to be null. That's why M was not printed. I have to take a character array of size 3 plus 1. That means of size 4. So this time I'll give 4 as the input, and let us see what happens. So if I give length 4 and now I give Tom, I'm getting Tom as a whole. So now I understand what is the significance of the last null character in C. You cannot store something which is equal to the length of the string. You have to store length minus 1. Next, we go to another way to take input from the user. Why not take the entire string as a whole? So we can use %s using scanf, but other variants also exist like gets, like fgets. There are many ways to take input. So either you can use scanf, or you can use gets, or you can use fgets, anyone. However, in practice, you will find the use of these two functions fgets and gets because they deal specifically with strings. We have preferred fgets. Why? Because fgets has some benefits over gets. And what is the difference between them? I think we have discussed it earlier, but still let us repeat once again. Gets, it takes the input until it encounters any end of the line or end of the file. However, fgets give you a customization option. What is that option? I can mention how many digits I want to scan, how many characters I want to scan. After that, I will stop. So if I mention 4, then after taking 4 characters, I will stop. Actually, I can customize this according to my wish. So fgets is more, you can say, flexible. Now let us try this program, and we have also printed this. Whatever we have taken, we are also printed that. Puts is the corresponding function of gets, and fputs is corresponding to fgets. Now why have we preferred puts? Because puts automatically takes us to the next line. So if you are a Python user, you must know that in Python, whenever we print something, we get to the new line automatically. So similarly, it works in that fashion. After printing a string, it takes us to the new line, and we want that to happen. Fputs does not take us to the new line, it keeps us in the same line. So that's why we have preferred using puts here. If we try to run this program and enter a string, again let us enter this time JD. Why are we getting only 3 letters? Because we have mentioned that size of the string will be 4. So the first 4 letters will be JER and that null character. So we are getting JER only. But if we mention something like this, suppose JERRY, that means 1 2 3 4 5. So let me enter 6 here. So I will give the size limit 6. So if I give the size limit 6, and now if I enter something like this JERRY, I should get the entire string, right, printed. Perfect, it's working fine. We go to the next program. Now this deals with the size of strings. Till now we have known how to take user input, how to print a string, how to declare and initialize a string. That means a character array, right? Now we will deal with the size of strings. And quite literally we use size of as the function to get the length of a string. You can inquire that in the previous examples when we used size of operator, like if we pass an array, it will give us the number of bytes occupied by the array. Then we had to divide it by the size of the data type to get the length of the array. But why don't we do this here? Because characters occupy 1 byte. Why to divide something by 1? So division by 1 is meaningless. That's why size of any string will automatically give us the length of the string. You can get the logic pretty well by just seeing this comment that size of the first element of the string is actually 1 byte. So if we try to print the size of a character, we will get 1 byte as the result. Let us try this as well. So we uncomment this. Let us print this on a new line. Here we have already given an input, so we are expecting the length as 1 2 3 4 5 6 7 8. So the length should be 8. Now if we try to print this, we get the length is 8 and the size of a character is 1 byte. Absolutely correct. Next, we proceed to the last program that we are going to see today. How to access elements of a string? So just like we accessed an element of an array, similarly we can access any element of a string. For simplicity, we have already given an example string. You can see it here. Now we have declared an integer array of the same size as that of this string, and what have we done? We are storing the ASCII values. We are typecasting the characters at ith position of the string. This is the same way we access the elements of an array, right? We inserted the index within square brackets and called the name of the array. Here the name of the string is str, and I am accessing its ith index. That will give me a character, and by typecasting I will get the ASCII value. Then we have printed character by character whatever is present in the string. We can also use directly puts so that we can get the entire string printed at a time. And finally what we have done, we have printed the array that is storing the ASCII values. So if we run this, we get first of all this string that we have already inserted into str. After that, we are getting the ASCII value of each and every member of the string. So the ASCII value of capital A is 65, we know this. Similarly, the ASCII values you can follow. W is 119, 0 is actually, it will give you 48, yes, and it goes on like this. So this is the result of this for loop that is printing the elements of the string, and this result is the outcome of this for loop that is printing the elements of the array. Fine, we have got a gentle introduction to strings in C. We know how to declare it, how to initialize it, how to calculate its size, how to print it in different ways using different functions. In the next class, we will see how to manipulate strings, and we'll do a lot of fun programs in it. So be ready for the next class, and that's all for today. Bye bye.